Next, we're going to look at what is called testing for a group of slope coefficients, and we'll be using what is called an F-test or an additional F-test, and we're going to discuss this with a new example. So first let's look at the example and then we'll come back to this test. So let's go to Excel file now, sheet 2. So here the data is the baseball salaries data. So baseball.xlsx. So here we have salaries of the baseball players, how many years in the majors. So ERA is career ERA, then innings pitched, okay, number of wins and number of losses. All right. So we'll be looking at predicted Y and E later on, but right now there are 5 predicted or independent variables, and then salary is the dependent variable that we want to forecast. Okay, let's define these terminologies. So dependent variable is salary in thousands, and independent variables except 1 is years in majors, except 2 is career ERA, except 3 innings pitched, except 4 is career wins, and except 5 is career losses. Okay, now let's use data analysis to generate the regression results. Data analysis, and we go regression. Okay. Y range is salary, and we'll include the label. Okay. Now in this case there is no estimation sample or holdout sample, so we'll include all the observations. Okay, labels. Okay, here is where we will start the regression output. Yeah, so here is the results, and we will format these results. Okay, now we want to test the overall model. Then the hypotheses are, so null hypothesis is that all the 5 slope coefficients are 0. The alternative is not all of them are 0. So let's use 5% level of significance. And we know the p-value is already generated right there. So let's use that p-value. Okay. So our conclusion is reject the null hypothesis. And the regression model is significant. Now if you want to look at the individual tests, okay, so for these 5 variables, the hypotheses are, so that's the first one, second one, so the third, 4 and 5. Okay, so let's use the p-value to test, and the p-values are readily available from here. The p-values are, these are the 5 p-values, not the intercept. Okay, so let's get the p-value down here, and we can use the transpose function to get all those p-values down there. So highlight the 5 cells, transpose, okay, p-value, close parenthesis, and this is an array function, so Control Shift Enter will get you the p-values down here, and the conclusions are if the p-value is less than or equal to also will work. Okay, and this needs to be absolute referenced. You reject, otherwise do not reject. Okay, so now right align this, and then you see here that these three are significant, but these two are not. Now that's kind of strange, because one would expect that when it comes to predicting salary, the number of wins and losses must be a significant factor. And how come this is not a significant factor, significant variable? Well, one of the reasons for that is that these two variables is probably very highly correlated, because when people who tend to have lots of wins, okay, they have played the game for many seasons, and so they would have accumulated lots of losses also. People who have very few wins will probably have very few losses as well, because they have not been in the league for a long period of time. Because anyone who has lots and lots of losses and no wins at all are probably not going to be in the league. Okay, so people who have lots of wins, okay, they are going to have reasonably, not equal number, but more losses than people who probably have been in the league for, say, only a couple of years. So you expect one of these two variables to be significant. Maybe the reason why both of them are turning out to be not significant is because one is robbing from the other the predictive ability. So if you have wins predicting the salaries, then losses need not be there, or vice versa. So when you put both of them there, they are competing with each other for the predictive ability, and they are stealing from each other, so to speak, and they both end up being not significant. Okay, so that's one reason this is called multicollinearity. We'll talk more about multicollinearity later on. But one of the ways in which we can test that these two variables go together, wins and losses, and we can see whether as a group is this variable significant or not. As a group, these two variables, we cannot use t-test because t-test is only for individual coefficients. So when you take a group of coefficients, how do you test whether that group as a group is significant or not? That's what we're going to look at in the next video.